Welcome, class. In this video, we will continue our introduction to exponential growth and exponential decay. In particular, we're going to go over compound interest problems. Our basic equation we use for compound interest is shown right here, where P is the original amount or the starting principal, T is the time, normally in years, R is the interest rate, and N is the number of times the money is compounded. So if it's monthly, well, there's 12 months in a year, so N would be 12. If it's quarterly, there are 4 quarters in a year, N would be 4. I just want to show how this equation is related to the simple interest equation, which is right here. Let's look at the basic equation here. Y equals some starting principal amount, 1 plus interest rate, N raised to the NT. We can convert any compound interest problem into a simple interest problem. Let's say we have a starting principal of $10,000 and we have an interest rate of 2.5%, which is 2.5 divided by 100, or 0.025. And let's say the money is compounded annually. This means N equals 1. So how much is the investment worth after 3 years? Let's use our equation. The starting amount is $10,000. 1 plus, because this is a growing, so it's a plus, interest rate of 0.025, it's going to be over N, raised to the NT. Keep in mind that this problem is compounded annually, so N equals 1. And up here, it would be 1 times T. If you notice, this is the same as writing $10,000, 1 plus 0.025 raised to the T. So when money is just compounded annually, it just becomes a simple interest equation. It's the same as the compound interest equation, just that N is equal to 1. And just be aware when we're going to change the N value. When interest is compounded monthly, N equals 12. When interest is compounded quarterly, N equals 4. When interest is compounded daily, N equals 365. And this is what credit cards typically charge. They're charging their compound interest daily, and you pay this amount at the end of each month. And just as a reminder, as you increase the number of times of compounding, or as N gets larger, the interest also grows faster. So whenever you have any kind of investment, or if you put money in a savings account or in a CD, it's good to find out how often is this interest compounded. The best offering you'll get is compounded daily at 365. On the other side, if you have a credit card, you want the interest compounded least often. Not the most often, but the least. But of course, credit card companies won't do that. They just compound it daily, so N equals 365. So you end up paying more interest. That's also why credit cards have, they'll tell you the interest is compounded daily, and they'll give you a certain rate, and then they'll give you what's called an APR, an annual, like sort of an annual percentage rate, because it won't be the same. You'll find the two percentages, what you're going to be paying, if you broke it down per day to what you pay at the end of the year, is not the same. So they actually have to adjust the rate. You're always going to think you're getting a lower rate. It might be like you're paying 15%. But the actual rate, when you compound interest, if you did the numbers, it might be like 16.5%. So just on your homework worksheet here, it's just some general information on here. You know, of course, for growth and decay, it's either 1 plus R or 1 minus R. So let's just take a look at the homework sheet here. Number 1, The bird population in a wooded area is decreasing by 3% each year from, from a population of 1250. And then 1B says find the population after 6 years. So let's first identify if this is exponential growth or decay. Because the population is decreasing, it is a decay. It's an exponential decay. Should probably write the whole, let's write the whole word here. Exponential decay. And it says, now let's use the formula. Well, the starting amount is going to be 1250. It's decreasing at a rate of 3%. What would that be as a decimal? Well, that is 0.03. And there's no compounding here with this population increasing. It's not an interest problem. It's really just a simple interest. We can think of it as n equals 1. This is 3% per year. N is 1. Okay. And it says, what is the population after 6 years? Now we're just going to type this into our calculator. Okay, our starting population is 1250. It's going to be 1 minus 0.03 raised to the 6. We get a population of 1,041. And there we go. That'll be the population of the birds decreasing at roughly 3% a year, because the percentage, of course, will always change each year, but that's an average of about 3% a year. 2A. A town's population was 3,800 in 2005, and it is growing at a rate of 2% every year. Is this an exponential growth or an exponential decay? Well, this is exponential growth. Let's find the population in the year 2025, starting from a year 2005. That would be year 0. So that means the time difference is going to be simply 20 years later. So the starting population is 3,800. The population is increasing at 2% a year, which is 0.02 for 20 years. What would be the town's population? Let's see here. A population starting off at 3,800, increasing at 2% a year, which is 1.02 for 20 years. The population, now these are people, so we need to round. We'll round up to 5,647 people. 3A. $800 is invested at a rate of 4% and is compounded monthly. Compounded monthly. And it tells us here, N here would equal 12. Is this a growth or a decay if the money is, if you have an investment? Well, we hope investments are always increasing. Sometimes they can decrease. A market can crash, right? But we'll assume here that it's increasing at 4% a year. So we'll call this exponential growth. So we have 4%. We know N is going to be 12, and they're telling us the time would be 10 years later. 10 years. How much is this $800 worth? So let's imagine now we have maybe perhaps a student is 8 years old, was given $800 savings bond, and it was appreciating at 4% a year compounded monthly. Let's see how much this $800 savings bond given to an 8-year-old would be worth. Remember now, it's 1 plus R over N. R is 0.04, N is 12. Raised to the NT, which is going to be N is 12 times 10. So it's raised to the 120th. You can kind of think of that as 120 periods of investment, because every month it's growing. 12 times a year, for 10 years. That's 120 periods of investment. Let's see how much this stock is worth. So we have $800, and it's going to be 1 plus 0.04 divided by 12. Let me close the parentheses. And we're going to raise it to the 120th power. So an $800 will be worth $1,192.67. And there you go. This will conclude the video over the reading strategies section 9.3.